Um, Now we continue on the second part of the amines and amides. We'll talk about the amines in plants, and those are called alkaloids. Alkaloids are organic compounds found in plants that have strong physiological and addictive effects on humans. Alkaloids are organic compounds. Of course, they have nitrogen, so they are weak bases, contain nitrogen, and therefore they are considered as weak bases, correct? And the name of alkaloids name is driven from the alkali-like compounds, which mean bases. They are considered as hydrocyclic and aromatic amines. So let's look at those some of the examples. Most of them are addictive, and most of them is a stimulant for the body, and some of them is very, very dangerous for our health. So caffeine, morphine, nicotine, quinine, sterolene, cocaine, sotanine, and it goes on and on and on. Those are the alkaloids. They are weak bases coming from the plants, and you can see other alkaloids. We can see them here: morphine, codeine, thebaine, and papaverine, papaverine, nosacabine, narcine. So those are alkaloids, weak bases, and coming from the plants. And here's just the harmful effects of alkaloids. You will see all of those are stimulants. All of those, they have very bad effect on the body, and they are very, very addictive. So nicotine, you can look at this. They can cause cancers. Most of them they can't cause, except maybe caffeine is not that bad, but all of those can cause a lot of other diseases and a lot of other problems, health problems for the human. And some of them are really drugs. I mean, like heroin, morphine, also act like a drug, and therefore they are very, very dangerous for our health. Now, amines in the humans. We'll talk about the neurotransmittance. The neurotransmittance. The neurotransmittance, we'll talk about them, but I'm not going through all this reading for you, but I'm going to back and forth between two figures. This is here the nerve cell. If I put this one here, this is a nerve cell. This nerve cell, as you see, this is the cell of the nucleus is inside, correct? And those are dendrites. That's like filaments in the top and the bottom. This you see here, the nerve cell, they have dendrites, so they can exchange information to other targeted cell. Okay, so we can look into this in the horizontal, to this neurotransmittance in the horizontal way. See, this is a horizontal way, and if you look at this, this is just a part here, small tiny part on the cell, and this explode and show you what's inside. So if you look at this, you have receptors, okay, and you have the other side, the dendrites, when they're accepting all this new information. You have this neurotransmittance trapped inside. They are trapped here inside the vesicles. They are trapping. So this is the blue one here, the inside. Those are the neurotransmittance. When enough pulse is coming, or electrical current through calcium voltage coming, they will be released into this area here, and this area called synaptic cleft. This area here called synaptic cleft. They will transfer, and they will be accepted by the receptors, correct? And the receptors taking them and then get them to the any target cell or any other nerve cell or any other neuron. And you can see here the long things here. This one here is blown up to you here, show you this. This is called axon. This is an axon. This is, and he is showing this is an axon here, as you can see. And this is the cell here. This is dendrites up and down, and this is the axon out of the cell. All those here, those are axons connected to the filaments. There are the small tiny filaments here. See here, those are accepting any message. But let's look at this, the whole thing vertical. So look at this in vertical way. Here it is. This is a nice way to look at the whole thing. So in the axon terminal, that's what we have seen. If I will go back and forth. So in this terminal here, see the axon terminal in this area here, you can see this is the axon, correct? And this one, they start, connecting themselves closer to the dendrites. Those are the dendrites, the filaments there. So now we have the transmittance trapped. We have seen this before, correct? The transmittance are those small tiny circles inside trapped in the synaptic vesicles. So vesicles here, synaptic vesicle, that's the whole thing is called synaptic vesicles, correct? They are trapped inside. Now, when they're trapped inside, when the time comes and there's enough current, correct, they will allow to get out of this their trapped cell here, and they can leave outside. So they can leave here outside. So they can leave outside from the axon terminal, correct? They can leave with the help, of course, there is a pump reuptake back and forth. They can be pumped up back and forth. So they go in, and then in the space here called synaptic cleft, we have synaptic vesicles. That's where the whole thing is trapped. And then they go in, and then there are receptors waiting for them, correct? They will attach to this receptor, and then they'll go further, connected to them to the filaments, to the dendrite spine. See here, they go to the dendrite spine. So this picture the same way, but this is vertical, while the picture there, we have seen it in a vertical way. This is vertical way, the same thing, they are released. This is the synaptic cleft, and this is the receptors. They come and attach them to the receptors, and then they will go from there to the filament, and they will convey by this process messages to new neurons or to new nerve cell or any other cells, for example, muscle cells and so on. So you can see back and forth with the picture. I like the way it's vertical, so I can see it. The neuron is trapped, the neurotransmitter is trapped inside. When the time is correct, the voltage will come, the electrical current will come and allow them to get out, and they can be pumped in and out. So they will get out, and they will attach themselves to the receptors. They are ready for them, and then from the receptor, then they can go to the dendrite spine through the filaments and then be transferred any messages they do carry. Okay, so this is just show you how the neurotransmittance, which they are amines, correct? And those neurotransmitters, they have very different functions, believe it or not, in the brain, in the nerve cells. Some of them for pleasure, responsible for the pleasure. Some of them from the mood, like dopamine. Dopamine is for the pleasure. Serotonin, this is for the mood. And concentration, this is noradrenaline, adrenaline, and the noradrenaline. One is for fight or flight. one for the concentration, and it goes GABA for calming, acetylcholine for the learning, correct? Memory is glutamate, and so on. So different neurotransmittance, different function in the nerve cells in the brain. So you can see how they are really controlling the function of the brain itself. So now this is these are the neurotransmittance, and those are the precursors. Here we have a precursors, so we can go from them from one to the other, from one to the other, and we can go from one to the other, and so on. So you can see we can go from one to the other one. So this is a precursor. So you start here and you'll end up producing neurotransmitters. And here is just give you another type of the neurotransmittance, which is aromatic this time. The aromatic neurotransmitters are called catecholamines, and they can be they are synthesized from the tyrosine. Tyrosine is found in the meat and the nuts and milk derivatives food. Amphetamine and methamphetamine are considered part of the catecholamines family. Both are strong stimulant and very addictive for the central nerve system. Amphetamine is used to treat attention deficit hyperactivity disorder in children. So ADHD, correct? And here just again show you whatever you start with the precursor, correct? And you produce the tyrosine, and then you produce those are neurotransmittance, correct? The neurotransmittance with their precursors. And the last thing here, I want just to look at the applications. We talked about the applications now, indirect or direct maybe, but the amines are a very good organic compounds that make organic dyes, adso dyes, and nylon. Amines also are used to make chemicals to protect the agricultural crops, to make drugs, and to purify water, and make chemical care products and pharmaceutical industry. Example of those, Demerol and morphine are used as painkillers. Ephedra is used as decongestant. Novocaine is used as anesthetic chemical. Amphetamine and methamphetamine are used as a drug after neutralizing them with an acid and transforming them into alkyl ammonium salt, which can be used as drugs. Kaolin is very important amine. If you recall, kaolin was what? Kaolin was an amine alcohol. Remember this, the previous, when we were talking the previous chapter about the sphingolipids and the lipids, and kaolin is part of the connected to the phospholipids, and kaolin is a very important, it's an amine, alcohol amine. So this amine is producing in the neurotransmittance and making the brain function well. So kaolin is very important for well functioning human being. Thank you very much for your